Okay, so we've got a functional here, which is the log of x cubed plus 3y, which is a function of x. Y is not a variable, it's a function of x. This is a functional, and minus 2y prime of x to the power of 4. And what we're looking for is the total derivative of this functional with regards to x. So as these two functions here are functions of x, we're going to need to use some kind of chain rule and partial derivative. So df dx, what we can say for that is df dx equals the partial of f with respect to x. So that'll be fine. There's no chain rule required for that one. But then we're going to need the partial of f with regards to y. So that'll be this function here. So I'm not going to write the y of x in here. You can just see that that is a function of x there. And then by the chain rule, we're going to need to multiply by the derivative of y with regards to x. So the derivative of y with regards to x. And then we're going to subtract this time. Got a minus sign here. And we're going to take the partial of f with regards to y prime. So that's this function here. And now we need to multiply by the derivative of y prime with regards to x, i.e. the chain rule. So that's going to give us dy prime dx. Now just to change the notation of these so it's in the same style as this one, I'm going to just change this a little bit. So partial of f with regards to x, that won't change. Partial of f with regards to y. And then dy dx, I'm just going to write that as y prime. Basically the derivative of y, so that's not changing anything. And then partial of f with regards to y prime. And then the derivative of y prime with regards to x is just y double prime. Okay, so now what we need to do is go along now and find all the partials, and then we can plug in them into this formula and see if we get the answer. So partial of f with regards to x. So let's make a little box here. So partial of f with regards to x. So as it's a log, the derivative of a log is going to be 1 over something. So 1 over something. And it's good, the something will be the inside of the brackets. So it's x cubed plus 3y. So it's going to write y this time rather than y of x. We now know it's a function of x. We kind of worked that out. And then minus 2y prime to the power of 4. Okay. Now by the chain rule, we need now to multiply by the derivative with regards to x of x cubed to be correct for the partial. So we can get rid of this 1 and write 3x squared. So that's the partial derivative with regards to x. So now we need the next one with regards to y. So partial of f with regards to y. Okay, so similar pattern. We take the derivative of this, it's going to be the 1 over something. So that's going to be the 1. I won't put the 1 in this time because we know we're going to get rid of that. But x cubed plus 3y minus 2y prime to the power of 4. And then chain rule, multiply by the derivative of 3y, which is just 3. Okay, so now the 2y prime to the power of 4. So partial of f with regards to y prime. Now I'm just going to not really listen to this minus sign here. I just want to take the derivative of this bit. Because when I plug it into the formula, I've got my minus sign here to take care of business as far as the minus sign is concerned. So I'm going to take the positive version here. So same again, be 1 over whatever's inside the logarithm. So that's x cubed plus 3y minus 2y prime to the power of 4. And now we take the derivative of this with regards to y prime. So we've got 4 will come out front. So that'll become an 8, 4 to the 8, and then drop this by 1. So that's 8y prime to the power of 3. So that's the derivative with regards to y prime. Okay, so now what we've got to do now is just plug these partials in here, and that'll give us our total derivative. So partial of f with regards to x, we've got 3x squared over x cubed plus 3y minus 2y prime to the power of 4. That's that taken care of. Partial of f with regards to y. So now we've got 3 over x cubed plus 3y minus 2y prime to the power of 4. And here we're going to have to multiply by y prime. So now we've got y prime. And now we're going to subtract, because we didn't use the minus sign here. So now subtract partial of f with regards to y prime, which is 8y prime cubed, over x cubed plus 3y minus 2y prime to the power of 4. And then multiplying by the second derivative. That's y double prime. Okay, so all it needs to do now is just to put all these in one fraction, and as the denominators are all the same, that's going to be pretty straightforward algebra. So the total derivative with regards to x of f, we can just write x cubed plus 3y minus 2y prime to the power of 4. Then simply add and subtract here. So 3x squared plus 3y prime minus 8y prime cubed y double prime. Just make that a little bit neater. Okay, and then that is the answer to our total derivative.